So good evening, one and all. This is Manikandan, Professor in the Department of Pharmaceutics, Sri Shanmugha College of Pharmacy. Today we are going to talk about the liposomal formulations. So in the previous videos we discussed about the liposomes, what is the definitions, what are the liposomes, applications, advantage, everything we discussed. The liposomes means it is a composed of vesicles of bilayer of phospholipids. Let's see what are the methods are going to prepare. There are several methods are used. So the passive loading technique and the active loading technique. In that the mechanical dispersion method and the solvent dispersion method and the detergents removal techniques. There are the several methods are available for the preparation of liposomes, especially for the passive loading techniques. In that lipid film hydration by hand shaking freeze drying technique or hand non-shaking freeze drying technique, and another one is the micro emulsification technique, the sonication. Then we can go for French pressure cell, then membrane extrusion technique, then dried reconstituted vesicles. So another the solvent dispersion method. When you talk about the solvent dispersion method, that ethanol injection, ether injection, and a double emulsion, a reverse phase osmosis technique, then stable pluripolar vesicles. By the way, the detergents removal technique. In that the detergents are removed from the micelles. Then by the dialysis method, then uh, chromatography, then diffusion and vesicle like reconstituted and sandy virus. Okay, so there are the several methods are used for the preparation of liposomes. So let's see what are the passive loading technique. In that the mechanical dispersion, solvent dispersion, and detergent solubilization method. In the mechanical dispersion method, especially we can use for the passive loading technique. The technique begin with the lipid solution in the organic solvents and end up with the lipid dispersion in water. So the various components are combined by co-dissolving the lipids in the organic solvent, in which then removed by the film deposition under the vacuum. Okay, so after the solvent is removed, the solid lipid mixture is hydrated by using a aqueous buffer. Okay, the lipid spontaneously swell and hydrates to form a liposomes. So பார்த்தீங்கன்னா lipids spontaneously swell ஆயிட்டு then and it will be to become a hydrate form ஆயிரும் in the form of liposomes. The post hydration treatment include the vortexing, sonication and freeze drying and extrusion technique. So see the diagrams are involved in the technique. In that the lipids are dissolved in the lipid soluble drugs, then the freeze-dry, then organic solvent, then in that the aqueous inclusion of the water soluble lipid drugs are added. With the lipid formation of cake is formed, then we can go for the hydration addition. Then initially the formation of lamellar large multilamellar vesicles are formed. Then we can go for the extrusion and homogenization technique. We can get the small multilamellar vesicles are obtained finally. So this is the grammatical pictures. The lipids dissolves in the organic solvent or co-solvent. They remove the organic solvent under the vacuum. Then finally the film is formed. Then the solid lipid mixture is hydrated by using a aqueous buffer. Then lipids spontaneously swell and hydrate. So finally the liposomes are formed. It may be available in the form of large multilamellar vesicles and small unilamellar vesicles are formed. So finally the post hydration vortexing, the sonication, freeze drying and extrusion pressure we will apply to obtain the liposomal preparations. So then we can move to the proliposomes. To increase the surface area of the dried lipid film and to facilitate the continuous hydrations, and lipid is dried over the finally particulate support. Example, we can use that sodium chloride and sorbitol or other polysaccharides. These dried lipid coated particulates are called proliposomes. Okay, as we discussed, these dried lipid coated particulates are called proliposomes. The proliposomes forms the dispersion of multilamellar vesicles on the addition of water where the support is rapidly dissolved and lipid film is hydrated to form a multilamellar vesicles. Okay, the method to overcome the stability problems and entrainment efficiency when the formulation of stable liposomes. When you talk about the liposomes that have some drawback like stability problems. Okay, so in the pro liposomes that we can overcome the stability problems of the liposomal formulations, then we can make a stable liposomes. So this is the diagrammatic pictures. So we can use that handshaking, the rotary flask evaporator. The film formation is obtained when we remove that nitrogen. The dried film is formed. Then film stack dispose in aqueous phase. Then we can add the hydration. The liposomal dispersion is formed. Then storage under the nitrogen umbrella. Store at 41 degree, so we can get the liposomal preparation. So this is a handshaking technique using the floating evaporation. Then sonication method, there are the several sonicator are used like a probe sonicator and a path sonicator is employed for the dispersion which require the high energy in a small volume, the high concentration of the lipids or various phase. The disadvantage of this method, it is called the lipid degradation due to the high energy, and sonication tips release the titanium particles into the liposomes dispersion. So that is one of the drawback of this method. Then we can move to that bath sonicator. The bath is more suitable for the large volume of diluted lipids. The placing the test tube containing the dispersion bath sonicator and sonicating for 5 to 10 minutes. 1 lakh gram in which yield the slightly hazy solutions. But then we can go for the centrifugation to yield the clear small unilamellar vesicles are formed by the sonication. There are two sonication method are used. One is probe sonication. When compared to the probe sonication, the bath sonicator is better. This is the diagrams. It shows that path sonication and probe sonications. Finally, the pure small unilamellar vesicles are formed. So, in the under part of that tube, we can aggregated liposomes are formed. Then French pressure liposomes, the ultrasonic radiation degraded the lipids, other sensitivity components, the macromolecules for this extrusion of preformed large liposomes in the French pressure under very high pressure is applied. This technique yield the unit or oligolamellar liposomes of such a size 30 to 80 nanometer in then include high cost of pressure that consists of the electric hydraulic pressure and pressure cell. The liposomes prepared by this method are very less likely to suffer from the defects and instability as observed in the sonicated vesicles. Okay, in such a method we can avoid the stability problems of the liposomes. So this is the French pressure method diagrams. In that we can prepare the liposomes. Another one, the microemulsification liposomes. The microfluidizer is used to prepare the small unilamellar vesicles and multilamellar vesicles from the concentrated lipid dispersion. The lipids can introduced into the fluidizer either as a dispersion of large multilamellar vesicles or the slurry of anhydride lipids in the organic medium. The microfluidizer pumps the fluid at very high pressure at 10,000 psi through the 5 micrometer orifice. Then it is forced along the defined microchannels which is direct into the two stream of fluids to collide together at the right angle at a very high velocity, thereby affecting the efficient transfer of energy. The fluid collected can be recycled through the pump and interaction the chamber until the vesicles of the spherical dimension are obtained. Okay, so after the single pass, the size of the vesicles are reduced into the 0.12 to 0.2 micrometer in diameter. Okay, we can administer the prepared multilamellar vesicle through the small orifice with the high pressure. So this is the instrument which we are used to prepare the liposomes. Micro fluidizer. Then the vesicles prepared by the extrusion technique, it is used to process the large unilamellar vesicles as well as the multilamellar vesicles. The liposome prepared by this technique are called membrane filter extrusion liposomes. 30% of capture volume can be obtained using the high lipid concentration, and the trapped volume in this process about 1 to 2 liter per mole of the lipids. It is due to their case of the production, the readily selected vesicles diameter batch to batch, the reproducibility and free from that solvent. So no need to use that any organic solvent or surfactant contaminations, that we can be avoided by this method. So this is the liposomes we can prepare by using the extrusion technique based on the polycarbonate filters. Then freeze drying the technique. This method is based on the freezing of unilamellar dispersion, then thawing at room temperature about 15 minutes. The process rupture and refuse the small unilamellar vesicles, during which the solid equilibrate between the inside and outside of the liposome themselves and fuse and increase the size. Okay, so each and every particles are fused together, they will become a large vesicles. The entrapment volume can be up to 30% of the total volume of the dispersion. So 10 microliter per milligram of the phospholipids we can use. We can use that sucrose, the divalent metal ions and high ionic strength salt solutions that we can use entrapped efficiently. This is the diagrams which shows the preparation of liposomes. We can use that small unilamellar vesicle in the aqueous phase, then with the solid for entrapped, then we can go for the freeze drying, then the freeze dried temperature, freeze dried membrane, then we can use that DRV method, then we can go for the rehydration and film stacks disposed in aqueous phase. So finally we can obtain the solution in the unilamellar or oligolamellar vesicles. So then the dried reconstituted vesicles, the liposomes obtained by this method are usually uni or oligolamellar in order to prepare the 0.1 micrometer or less than diameter. The small unilamellar in aqueous phase with the solid to be entrapped the freeze dried membrane. The solid in a unilamellar vesicles, the solid in a uni or oligolamellar vesicles. This method the rehydration film stacks the dispersion aqueous phase during the sonication, the 15 to 30 seconds. So another one, the detergent solubilization method. In that we can reuse that detergent. The phospholipids brought into that intimate contact with the aqueous phase. Then by the addition of optimized concentration of the detergents, we can use that optimized concentration only. So finally, the formation of micelles are formed. We can obtain the liposomes with the various size. So finally we can go for the purifications. So thank you. There are the several methods we are discussed about the preparation of liposomes, membrane filtration technique and microfluidizer technique, then freeze drying technique, then detergent solubilization technique. So all the methods are having some drawback and advantage. So we can use that specific method. There is no specific method for the preparation of liposomes. So we can choose that which type of method is suitable for the preparation of unilamellar or oligolamellar vesicles or small unilamellar vesicles or multilamellar vesicles, that we can use depends upon the method of preparation. Okay, so remaining the active loading technique will be discussed on next video. Thank you.